Okay, let's review. It's very difficult for us to be able to take antiderivatives or find indefinite integrals of things that involve products, of things that involve quotients, but there are methods for doing it, and we learned a process called substitution. Very similar to the chain rule, except we really kind of perform it backwards. And so we identify U. What is U going to be equal to in this scenario? 4 plus x to the third. And generally speaking, what U is U is the inside piece of the function. Not all the time, but generally speaking, is the inside piece. And here's how I know that it's 4 plus x to the third, because when I take the derivative, what do I get? So I want U to be something that when I take the derivative, something else pops up. So the derivative of U is equal to 3x squared dx. I have to account for all the pieces. So notice what I have here. The 3x squared is right there. The dx is right here. And the 4 plus x to the third is right here. So all my pieces are accounted for. I may now rewrite this as the integral of u to the fourth du. Correct? That's it. Now I take the antiderivative. What is the antiderivative of u to the fourth? U to the fifth over 5 plus c. What is my final step? Plug u back in, and I get 4 plus x plus x to the third to the fifth over 5 plus c. And that is the antiderivative. Something that, is not easy to find, but we made it a lot easier than what it could have been. Notice we could have turned this into a polynomial by taking it to the fourth power and then distributing terms and doing it all, separately, but that would have taken a lot of time. This way I did it pretty quick. Any questions on that? If you were to take it to the fourth, yes, it wouldn't look the same, but it is the same. Do you guys want to try number 2 on your own? See if you could get it? We can look at those, but I do want to do these 6. Yeah. Right. Sure. But what do I identify U as? I have a problem. My problem is that I have an 8, but here I have a 7. So what I like to do is this. I like to rewrite the definite integral, and I rewrite it like this, or the indefinite integral, to be 7 times the integral of x parentheses 4x squared minus 3 dx. So if I move the constant out front, that makes it a little bit better. I moved the 7 out, to the third power. So if I move the 7 out front, and you're allowed to move constants out front, if you notice here, I have this exact piece right here, except I don't want this 8, right? So I divide off the 8. So I have 1/8 of du is equal to x dx. Question, Chelsea. The derivative of 4x squared minus 3 is 8x dx. So now I solved here, so I just have an x dx, and up here you have an x dx as well. So now I've accounted for the pieces I need to, and so my new integral will read something like this. The integral with a 7 out front times u to the third times 1/8 du. Where can I move the 1/8? Out front, so 7 over 8. That's my new integral. This x right here, this x dx, so the dx and the x, that gets replaced by 1/8 du. So du and 1/8. It's all about, you guys, the first time I saw this, I didn't understand what my teacher was telling me. I didn't understand what was happening. All we are doing is replacing every piece with something else. Everything is by substitution. Everything is by substitution. So now I evaluate, what's the integral, what's u to the third? What's the antiderivative? So I have 7 over 8 times u to the fourth over 4 plus c, right? And now I substitute u back in, and I get 7 times 4x squared minus 3 to the fourth power over 32 plus c. And that is my antiderivative. That is the result of the indefinite integral. Any questions on problem number 2? Three looks difficult. It's not that bad. Question? Yes. If you look, it's exactly what I have. If it's exactly the same, then great. If it's not, then I gotta work with it and make it look different. And you guys, I just want you to know that we've done really a one substitution piece right now. We're substituting one thing in. On Wednesday, I would like to move to where we actually do 2 different substitutions. And that will be the maximum that you'll see for the content of your test. I don't even mess around anymore. I just removed the negative 2/3 right away. I have absolutely no desire to work with the constants. And you'll continue to do that as you move through calculus. You'll just move the constants out. And even though you could do the math with it there's just no point. Okay? Boys. No, you may not cancel the square roots. Okay? This is not cosine times square root of x. This is the cosine of the square root of x. And you can't cancel a composition with something in the denominator. It doesn't work like that. So, any idea what u might be in this situation? U is equal to the square root of x. And so that means that du is equal to, what is the derivative of the square root of x? It's okay, you guys. You're all making the same mistake. Let's watch this. It's x to the 1/2. The derivative is equal to 1 over 2 times x to the negative 1/2, which would be 1 over 2 x to the, shh, guys. 1 over 2x to the 1/2 is what we get, or 1 over 2 square roots of x. So the derivative in this situation is 1 over 2 times the square root, 1 over 2 square roots of x. Right. 1 over 2 square roots of x. So that's what du is. Now, let's look at our function. Okay? I can replace this square root of x with u. So I'd have the cosine of u. And I have a dx on top. Whoop, I'm sorry. 1 over 2 square roots of x dx. I have the dx here, and I have a square root of x on bottom, and I do have a square root of x on bottom. But what extra thing do I have here that I have to get rid of? 2. So I should rewrite this to be 2 du is equal to 1 over the square root of x dx. And so I have a square root of x in the denominator and a dx, and that can be replaced now by 2 du. I just multiply both sides by 2 and I get that. Yep. So my new integral will be negative 2 over 3 times the integral of cosine of u times 2 du. What can I do with that 2? Just move it out front, so you'd have a negative 4/3. So this becomes negative 4 over 3 times the integral of cosine of u du. Again, go ahead, question. This one? Oh, excellent, excellent, excellent point. No. Here's the reason why. As you look at this problem, see this x here? That came up when we took the derivative, right? Well, this x in the denominator comes up when we take the derivative as well. So we're accounting for the square root of x. What's that? The u accounts for that. The 2 du accounts for the one in the denominator. The du accounts for the one in the denominator. Just like up here, Claire, u accounted for 4x squared minus 3, but the du helped account for the x. Okay? Same process. So now we evaluate this. What is the antiderivative of cosine? Sine. So I have negative 4 over 3 times the sine of u plus c. And I can replace that u with what? The square root of x. There's my antiderivative. Now I want to do 3 more, and then you guys are going to have some time to practice this. We do have an extensive assignment, and you guys will be given all day tomorrow to work on it, and part of Wednesday as well. If you look at number 4, please appreciate the complexity. 4 plus tangent squared all to the 3rd power times secant squared of x dx. This looks like a ridiculously difficult antiderivative to find. And you know what? It is written in a nice way such that it works out, but we are learning a lot of techniques which allow us to find a lot of antiderivatives. There are some out there that we cannot find. I'll just give you one example. E to the x squared, there is not an antiderivative of that we can find. We can approximate one, but you can't find one. And so there are some that are just, they flat out don't exist. Well, they do exist, we can't find a formula for it. Only approximation. So we don't know the derivative of tan squared x. So we'll get rid of the square. Actually, I'm sorry. Actually, we do know how to find the derivative of tan squared, but it's a lot more involved. When I wrote this problem, understand I'm writing it trying to see the whole solution ahead of time, and we don't want to do that one. So we'll do this. So you, Doctor. Okay, so u is equal to, in this situation, we're going to take 4 plus the tangent of x. That means that du is equal to what? Secant squared of x dx. Well, if you look in this problem, you have a secant squared, you have a dx, and this 4 plus tangent of x, now that I've gotten rid of the squared piece, is all accounted for. So my new integral, very good, Taylor Blake, is simply the integral of u to the third du. Please do not forget to write the du. And the integral of u to the third du is u to the fourth over 4 plus c. We now take our u value, which is 4 plus tangent of x, substitute it back in. And we have a beautiful antiderivative. I'll give you guys your assignment, yeah. This is just notes. Number 5, we're going to do 1 minus x squared. So I choose to write this one like this. I choose to pull the 3 out right away, and then I just write it like the polynomial, or I'm sorry, I write it like the product that we saw in the previous ones. Yes, it does end up being the denominator, but for me it's about familiarity. And so I think that you guys will resonate more with this than you would the other way. So I see this piece, and I'm going to work with this, and then we'll get to something else later. So what do I choose u to be in this situation? U is equal to 1 minus x squared. So that means that du is equal to negative 2x dx. Now, as we look at our problem, we're missing a couple pieces, aren't we? We're missing the negative and the 2. So we should divide by. So that means that negative 1/2 du is equal to x dx. Now, I could take this negative 1/2 u du and substitute it in for my x and my dx. I've accounted for those pieces. So I'm going to write my new integral, and I'm going to have the 3 out front, and I'm going to take this negative 1/2 from the du, and I'm going to move that out front as well. And now I simply have u to the negative 1/2 power du. Again, all of the pieces are accounted for. What is the antiderivative of u to the negative 1/2? 2u to the 1/2. Very good, plus c. Remember your negative 3/2 out front that you need to use. What happens to the 2's? They cancel. I get negative 3. Yes. Negative 3 times the square root of 1 minus x squared plus c. And there's my result. Any questions on number 5 before we move to 6? Questions going once? Going twice? 3 times. We try the last one. Do you want to try the last one on your own? Okay. I thought you maybe want to try it on your own, see kind of where you got. Okay, I'm gonna rewrite this for that. I will, yeah. I'm gonna rewrite it as the integral of 4x plus 2 in parentheses times x squared plus x minus 1 to the negative 3 power dx. So I rewrote it like that. What is u? X squared plus x minus 1. So du is equal to 2x plus 1 dx. What's the problem, folks? Halvesies. Very good. Blake sees that you got 4x plus 2. Here you got 2x plus 1. So what should I multiply this by? 2. If I multiply this side by 2, I multiply. So I end up with 2 du is equal to 4x plus 2 dx. So as you notice here, now I can account for everything and substitute it in. So, you know, it's about manipulating the equation to make it look like what you need it to in order to do your substitution process. So now we've accounted for everything. We have 2 du will take the place of this, and u will take the place of that. So I've covered everything. So my new integral will read the integral of u to the negative third times 2, I'll write that out front, du. What is the antiderivative of u to the negative third? U to the negative 2 over negative 2 times the 2 in front, du. What? I'm sorry, don't need that. It's plus c. Correct me if I'm wrong, but that's just equal to 1 over, or negative 1 over u squared plus c, correct? Which is negative 1 over x squared plus x minus 1. Quantity squared plus c. Make a box, check it if you're done. I'm done. There you go. Get it? Now, Colleen's our true measure because Colleen wasn't here on Friday, and neither was Bryce. Anybody else other than Colleen and Bryce? And Christian. So for those who weren't here, think you get it? Okay, okay, all right. Well, all right. Well, Christian's got it. Bryce and Colleen need some help, it sounds like. All right.